Okay, so I had to be out today. We have an away game down in Mattawa. So I apologize for not being here, but I figured I would leave you guys some notes to get going off of. And this is going to be basically just a review of what we had introduced yesterday, which was talking about our point slope form. So, point slope form, first of all, literally we're talking about a point and the slope. So your point slope form is right there. Y minus y1 equals m times x minus x1. So that means we need, just like it says, we need a point. Well, we're given on this graph a point right there, which is at -4, +3. And we need the slope. And notice I did say a point and the slope, because you can use any point on the line, but the slope is constant, so the slope will always be the same. So we need a point and we need the slope, and we are given the slope right there. So we're already given everything we need to go right into this point slope form. So let's do that. So we're going to put y minus y1, and we're going to make this point x1, y1, because that was given to us for some reason, so we're going to use that specific point. So y1 is 3 equals m, that's your -3/4 that we were also given, times x minus x1, which is a -4. And make sure you have that minus and negative in there, because that changes things, obviously. Okay, well, that's actually it. That is point slope form. That's the equation of the line. However, it's not nearly as useful as slope intercept form. So we want to take this from point slope form and go to slope intercept form. And it's really only a couple of steps. So we're dc/vcd. The first thing we would need to do is distributive property. And if you see right here is where we have our distributive property. Make sure we take that minus and negative, make it a plus. Now we're distributing the -3/4. -3/4 times x is just -3/4 x. -3/4 times a +4 is going to be a negative, and then really just the 4's cancel, so a -3. And then last thing we got to do here to solve it for y is add 3 to both sides. That's going to give me y equals -3/4 x, and I guess technically +0, although that doesn't really matter, but it makes it fit our slope intercept form. So that now fits our y equals mx plus b really nicely. Okay, well, let's see what we're talking about here. So let's go back to our initial information. We were given -4/3 and a slope of -3/4. So we could have just gone down 3 to the right 4, gotten ourselves another point, and you would have the graph of that line already. Perfect. Okay. But what we wanted was the equation. So we went through and we found our equation, and that all looked pretty good. We ended up with -3/4 x plus 0. That would mean our y-intercept is 0, right? Which was right there. And from there, if we were graphing using mx plus b, we'd go down 1, 2, 3, right 1, 2, 3, 4, and you are right on the same line. So that's kind of how everything ties together there, okay? I'm going to go through the rest of them a little bit quicker, but that's just kind of a review of everything we talked about yesterday. Okay, well, let's say we are given a point and the slope. Well, a point, the slope, and we're going into this form where we need to plug in a point. So let's call it x1, y1, and the slope. And now we can just simplify this because we want to get it into slope intercept form. That's going to be a y plus 3. Over here we're going to distribute. That's 4x minus 4. Subtract your 3 from both sides, and y equals 4x minus 7. There is the slope-intercept form of the line that passes through 1, negative 3 and has a slope of 4. Okay? And we could, again, I'm not going to ask you to graph, okay, but if I do just a quick sketch here. 1, negative 3, we're talking about right there for that initial point. Slope of 4 would tell me to go up 4 from there, right 1. So up 1, 2, 3, 4, right 1 would be right about there. So there roughly would be that graph. And then from mx plus b, I have a b that is negative 7. 4, 5, 6, 7. That seems to match up pretty good. And then I would go up 4, right 1, and there you have it. Everything kind of ties together again there. Slope-intercept from point-slope form. Okay, another one just like that. So again, we are plugging into point-slope form. So what I need to plug in is a point right there. So I'm going to call that my x1, y1. Okay, it's y minus y1, x minus x1. And I'm going to plug in my slope, 5 over 3. And that's it. That's your point-slope form, but we always want to convert that to slope-intercept form. So first thing I'm going to do is distribute my 5/3. That's just 5/3 x minus 5. Add over your 3, and you end up with 5/3 x minus 2. And once again, that 5 over 3, that's the slope, right? We actually started with that. And then by putting it into slope-intercept form, we're also going to get out of it that y-intercept right there. Okay. Now, the kind of the hardest way to do it is actually what we started with. So when you are given 2 points here, okay, so we're given 1 point there, another point there. Well, this is kind of the most work you have to do. So we need our slope. So that's the first thing we're going to have to do is find our slope. Well, our form there to find the slope is going to be y2 minus y1 over x2 minus x1. So it looks just like that. When we plug the right numbers in there, we got y2, 5, x2, 1, y1, negative 1, x1, also negative 1. And then don't forget your minus signs from the form. Clean this up. That's going to give us a slope that is 5 plus 1, 6, over 1 plus 1, 2, or in other words, 3. Okay, and now we're going to go to our slope-intercept form, or I'm sorry, point-slope form first. So we're going to plug in either point, and it really does not matter which point. And just to show you, I'll use the second one here. We've been using the first. But if I plug in my x2 and my y2, so the 5 and the 1, we're still going to be good. Now, make sure, if you're using the second point, use the x and the y from that point, because that would matter. Can't use an x from one point and a y from another point. Oh, that'll screw you up. And then we just found our slope was 3. And we're going to go to slope-intercept, which means we're going to distribute. And then we just have to add our 5 over to get 3x plus 2. And once again, there's my slope. And there's my y-intercept. And that is the equation we're after. Okay. Hopefully you're getting the hang of it, but let's do one more here just to be sure. And I'll keep kind of getting a little bit quicker here. So we're talking 2 different points. So we know we're going to have to find that slope first. So let's go x1, y1, x2, y2. We're going to have to find slope, which means we're plugging in y2, x2 minus y1, x1. Clean this up. 3 minus 5. This is going to have to turn to a plus. Negative 3 plus 9 is going to be 6. That's a negative 1/3 for our slope. Let's go to point slope form. And if you're getting bored with this already, then great. That probably means it's sinking in pretty good for you. So negative 1/3 is our slope. Again, we can use either point. Let's go with our x1, y1 in this case. So that's 5. That's a negative 9. Start cleaning it up. I'm going to distribute a negative 1/3, which is just negative 1/3 x. And then negative 1/3 times positive 9. 3 into 9 goes 3. Times 1 is 3. That's a minus times a plus, or a negative times a positive, so minus. Add over my 5. And there we have it. Plus 2. And that was supposed to be a 3 there. Sorry, guys. Okay, and that's it, right? There's your slope, just like we had found over in the beginning. And then that 2 gives us our y-intercept. And there's the equation that you're looking for. All right, and last thing, let's take a look at a word problem here as well, or an application problem. So you water plants in your classroom at a constant rate. After 5 seconds, your watering can contains 58 ounces of water. 15 seconds later, the can contains 28 ounces of water. Okay, so we got some important information there. We're talking about amount of water, so 58 ounces, 28 ounces, and then we're also talking about time here, 5 seconds, 15 seconds. Okay, let's see where this is taking us. A says write an equation that represents the amount y in ounces. Okay, so y is going to be our ounces of water. Ounces of water. And x time in seconds. Okay, well, x and y, so actually really what we're being given here is points, right? So we're being given at 5 seconds, we have 58 ounces of water. At 15 seconds, 28 ounces of water. Okay, well, we can work with that, right? If that's in x comma y, so 5 comma 58, and another x comma y, 15 comma 28, well then that's something we can work with, right? So that's looking very similar now to 2 points. With 2 points, we can find that slope, x1, y1, x2, y2. That's going to put us into point slope form. So we need our slope. Sorry about that. So we want to find point slope form. So we're going to need to find that m, right? Well, m is going to be y2 minus y1 over x2 minus x1. Okay, well 28 minus 58 is negative 30. 15 minus 5 is 10, so this simplifies down to negative 3 for our m. So that goes right in there. And then we can pick either point. I guess 15 and 28 are the smaller numbers. Really doesn't matter which way you go. So if I put in 15 and 28 as my point, I'm looking at this. And when I start to clean that up, I've now got distribute over here. That's a negative 3x plus 45. Add my 28 over. It's going to give me a negative 3x plus 60, 73. Okay, well, we know this is our slope. Now think about this in terms of what we're talking about. If it's y over x, that's ounces of water over seconds, right? So negative 3 ounces of water per second. So this is something draining, right? So we're watering plants, so a watering can, yeah, so it makes sense that's going to be a negative, right? Because that's going to be pouring out of there. So negative 3 ounces per second. So that's basically the speed that water is pouring out of there. So that makes sense. So then we also have a y-intercept at 73. Well, y-intercept is, if that's our starting point, well, then that must be how much we started with, right? So 73 ounces is how much water was in the can to start. And when is the watering can empty? Well, that would be when we have no more y, right? So 0. So we divide that 73 by 3, right around 21 seconds. Okay. Or actually, I'm sorry, 3 into 73 goes twice, 1 left, about 24 seconds. Right about 24 seconds. That's going to empty out. So that's kind of just interpreting there your slope and your y-intercept. Okay. That should do it. Good luck on the assignment. Remember that assignment once again. And this is going to be due on Monday. It's the 4.7 assignment. That's page 188. And we are doing questions 3 through 19, just doing the odds. And obviously you should have pretty good examples of those. I'll also put this into Google Classroom.